Today, I'm going to show you something of the future. This is our next generation of graphics technology. We call it Neuro Rendering, the fusion of 3D graphics and artificial intelligence. This is DLSS 5. Take a look at it. Is that incredible? Computer graphics comes to life. Now, what did we do? We fused controllable 3D graphics, the ground truth of virtual worlds, the structured data. Remember this word, the structured data of virtual worlds, of generated worlds. We combine 3D graphics, structured data, with generative AI, probabilistic computing. One of them is completely predictive, the other one probabilistic, yet highly realistic. We combine these two ideas, controlled through structured data, controlled perfectly, and yet generating at the same time. And as a result, the content is beautiful, amazing, as well as controllable. This concept of fusing structured information and generative AI will repeat itself in one industry after another industry after another industry. Structured data is the foundation of trustworthy AI. Well, this is going to scare you a little bit. I'm going to flip the slide, and don't gasp. So we're going to go through this schematic for the rest of the time. This is my best slide. Every time I ask the team, what's my best slide? Repeatedly, this was it. They say, don't do it, Jensen. Don't do it. I said, no. These seats are free for some of you. So this is your price of admission. So this is structured data. You've heard of it. SQL, Spark, Pandas, Velox, some of these really, really important, very large platforms, Snowflake, Databricks, EMR, Amazon EMR, Azure Fabric, Google Cloud, BigQuery. All of these platforms are processing data frames. These data frames are giant spreadsheets, and they hold all of life's information. This is the structured data, the ground truth of business. This is the ground truth of enterprise computing. Well, now we're going to have AI use structured data, and we better accelerate the living daylights out of it. It used to be okay, and we would, of course, we would accelerate structured data so that we could do more, we could do it more cheaply, we could do it more frequently per day, and keep the company running at a much more synchronized way. However, in the future, what's going to happen is these data structures are going to be used by AI, and AI is going to be much, much faster than us. Future agents are going to use structured databases as well. And then, of course, the unstructured database, the generative database. This database represents the vast majority of the world. Vector databases, unstructured data, PDFs, videos, speeches, all of the world's information, about 90% of what's generated every single year is unstructured data. Until now, this data has been completely useless to the world. We read it, we put it into our file system, and that's it. Unfortunately, we can't query it. We can't search for it. It's hard to do that. And the reason for that is because there's no easy indexing of unstructured data. You have to understand its meaning, its purpose. And so now we have AI do that. Just as AI was able to solve multi-modality perception and understanding, you can use that same technology, multimodality perception and understanding, to go read a PDF, to understand its meaning. And from that meaning, embed it into a larger structure that we can search into, we can query into. NVIDIA created 2 foundational libraries, just like we created RTX for 3D graphics. We created cuDF for data frames, structured data. We created cuVS for vector stores, semantic data, unstructured data, AI data. These 2 platforms are going to be 2 of the most important platforms in the future. Super excited to see its adoption throughout the network, this complicated network of the world's data processing systems. And the reason for that is because data processing has been around a long time. And therefore, so many different companies and platforms and services, it has taken us a long time to integrate deeply into this ecosystem. I'm super proud of the work that we're doing here. And then today, we're announcing several of them. IBM, the inventor of SQL, one of the most important domain-specific languages of all time, is accelerating Watson X data with cuDF. Let's take a look at it.
60 years ago, IBM introduced the System 360, the first modern platform for general-purpose computing, launching the computing era. Then SQL, a declarative language to query data without requiring the computer to be instructed step by step. And the data warehouse, each the foundations of modern enterprise computing. Today, IBM and NVIDIA are reinventing data processing for the era of AI by accelerating IBM Watson X data SQL engines with NVIDIA GPU computing libraries. Data is the ground truth that gives AI context and meaning. AI needs rapid access to massive datasets. Today's CPU data processing systems can't keep up. Nestle makes thousands of supply chain decisions every day. Their order-to-cash data mart aggregates every supply, order, and delivery event across global operations in 185 countries. On CPUs, Nestle refreshed the data mart a few times a day. With accelerated Watson X data running on NVIDIA GPUs, Nestle can run the same workload 5 times faster at 83% lower cost. The next computing platform has arrived, accelerated computing for the era of AI.
NVIDIA accelerates data processing in the cloud. We also accelerate data processing on-prem. As you know, Dell is the world-leading computer systems maker, and they also are one of the world's leading storage providers. And they worked with us to create the Dell AI data platform that integrates cuDF and cuVS to create an accelerated data platform, well, for the era of AI. And this is an example of what they did with NTT Data, huge speed up. This is Google Cloud, and Google Cloud, as you know, we've been working with Google Cloud for a very long time. We accelerate Google's Vertex AI. We now accelerate BigQuery, really important framework and really important platform. And this is an example of our work together with Snapchat, where we reduced their cost of computing by nearly 80%. When you accelerate data processing, when you accelerate computing, you get the benefit of speed, you get the benefit of scale, but most importantly, you also get the benefit of cost. And so all of those come together as one. It was originally called Moore's Law. Moore's Law was about getting performance doubling every couple of years. It's another way of saying, so long as the price remains about the same, and most computers remained about the same, you're also getting twice the performance every year, or you're reducing the cost of computing every single year. Well, Moore's Law has run out of steam. We need a new approach. Accelerated computing allows us to take these giant leaps forward. And as you will see later, because we continue to optimize the algorithms, and NVIDIA is an algorithm company, as we continue to optimize the algorithms, and because our reach is so large and our install base is so large, we can reduce the computing cost, increasing the scale, increasing the speed for everybody continuously. This is Google Cloud. You could see this pattern I just mentioned. I just wanted to show you 3 versions of it. NVIDIA built the accelerated computing platform. Has a bunch of libraries on top. I gave you 3 examples. RTX is one of them, cuDF is another, cuVS, and we'll show you a few more. These libraries sit on top of our platform. But ultimately, we integrate into the world's cloud services, into the world's OEMs, and together, and other platforms that I'll show you, together, we're able to reach the world. This pattern, NVIDIA, Google Cloud, Snapchat, will repeat over and over again, and it kind of looks like this. And so this is one example, NVIDIA with Google Cloud. We accelerate Vertex AI. We accelerate BigQuery. I'm super proud of the work that we've done with JAX and XLA. We're incredible on PyTorch. We're the only accelerator in the world that's incredible on PyTorch and incredible on JAX and XLA. And the customers that we support, the Base 10s, the CrowdStrikes, Puma, Salesforce, they're not our customers, but they're customers, developers of ours that we've integrated the NVIDIA technologies into that we can then land on the clouds. Our relationship with cloud service providers are essentially us bringing customers to them. We integrate our libraries, we accelerate workloads, and we land those customers in the clouds. And so, as you could see, most of our cloud service providers love working with us, and they're always asking us to land the next customer on their cloud. And I just want to let you know, there are a lot of customers. We're going to accelerate everybody. And so there'll be lots and lots of customers we'll be able to land in your cloud. Just be patient with us. And so this is Google Cloud. This is AWS. We've been working with AWS a long time. And one of the things I'm super excited about this year is we're going to bring OpenAI to AWS. And so it's going to drive enormous consumption of cloud computing at AWS. It's going to expand the reach and expand the compute of OpenAI. And as you know, they are completely compute constrained. And so AWS, we accelerate EMR, we accelerate SageMaker, we accelerate Bedrock. NVIDIA's integrated really deeply into AWS. They were our first cloud partner. Microsoft Azure. NVIDIA's A100 supercomputer was the first one we built was for NVIDIA. The first one we installed was at Azure. And that led to the big successful partnership with OpenAI. But we've been working with Azure for quite a long time. We accelerate Azure Cloud. Now it's their AI Foundry we partner deeply with. We accelerate Bing Search. We work with them on Azure regions. This is one of the areas that is incredibly important as we continue to expand AI throughout the world. One of the capabilities that we offer is confidential computing. That in confidential computing, you want to make sure that even the operator cannot see your data. Even the operator cannot touch or see your models. Confidential computing, NVIDIA's GPUs is the first ones in the world to do that. It's now able to support confidential computing and protected deployment of these very valuable OpenAI models and Anthropic models throughout clouds and different regions, and all because of our confidential computing. Confidential computing is super important. And here's an example where we have different customers that we work with. Synopsys, a great partner of ours, we're accelerating all of their EDA and CAE workflows. And then we landed at Microsoft Azure. We were Oracle's first AI customer. Most people would have thought we were their first supplier. We were their first supplier also, but we were their first AI customer. I'm quite proud of the fact that I explained AI clouds to Oracle for the first time, and we were their first customer. Since then, they've really taken off. We've landed a whole bunch of our partners there, Cohere and Fireworks, and of course, very famously, OpenAI. A great partnership with CoreWeave. They're the world's first AI native cloud, a company that was built with only one singular purpose: to provision, to host GPUs as the era of accelerated computing showed up, and to host for AI clouds. They've got some fantastic customers, and they're growing incredibly. One of the platforms that I'm quite excited about is Palantir and Dell. The three of our companies have made it possible to stand up a brand new type of AI platform, the Palantir Ontology platform, an AI platform. And we could stand up these platforms in any country, in any air-gapped region, completely on-prem, completely on-site, completely in the field. AI could be deployed literally everywhere. Without our confidential computing capability, without our ability to build the end-to-end system, as well as offer the entire accelerated computing and AI stack, from data processing, whether it's vectors or structures, all the way to AI, it wouldn't have been possible. I wanted to show you these examples. This is our special working relationship with the world's cloud service providers. And all of them are here. And I get the benefit of seeing them during booth tour, and it's just so incredibly exciting. I just want to thank all of you for the hard work. What NVIDIA has done is this, and you're going to see this theme over and over again. NVIDIA is vertically integrated, the world's first vertically integrated but horizontally open company. And the reason that's necessary is very simple. Accelerated computing is not a chip problem. Accelerated computing is not a systems problem. Accelerated computing has a missing word. We just never say it anymore. Application acceleration. If I could make a computer run everything faster, that's called a CPU. But that's run out of steam. The only way for us to accelerate applications going forward and continue to bring tremendous speed up, tremendous cost reduction, is through application or domain-specific acceleration. I dropped that phrase in the front, and therefore it just became accelerated computing. And that is the reason why NVIDIA has to be library after library, domain after domain, vertical after vertical. We are a vertically integrated computing company. There is no other way. We have to understand the applications, we have to understand the domain, we have to understand fundamentally the algorithms, and we have to figure out how to deploy the algorithm in whatever scenario it wants to be deployed, whether it's a data center, cloud, on-prem, at the edge, or in a robotic system. All of those computing systems are different. And finally, the systems and chips. We are vertically integrated. What makes it incredibly powerful, and the reason why you saw all the slides, is because NVIDIA is horizontally open. We'll work and integrate NVIDIA's technology into whatever platform you would like us to integrate into. We offer you the software, we offer you libraries, we integrate with your technology so that we can bring accelerated computing to everybody in the world. Well, this GTC is really a great demonstration of that. You know, most of the time you'll see me talk about these verticals, and I'll use some examples. But in every single case, whether it's automotive, by the way, financial services, the largest percentage of attendees at this GTC is from the financial services industry. I know. I'm hoping it's developers, not traders. Guys. Here's one thing I wanted to say. And so, in the audience represents NVIDIA's ecosystem upstream of our supply chain and downstream of our supply chain. And we think about our supply chain upstream and downstream. And it's just so exciting that our entire upstream supply chain this last year, irrespective of whether you're a 50-year-old company, we have 70-year-old companies, we have a 150-year-old company who are now part of NVIDIA's supply chain and partnering with us either upstream or downstream. And last year, You had your record year, did you not? Congratulations. We're on to something here. This is the beginning of something very, very big. And so if you look at accelerated computing, we've now set the computing platform, but in order for us to activate those computing platforms, we need to have domain-specific libraries that solve very important problems in each one of the verticals that we address. You see us addressing every single one of this. Autonomous vehicles, our reach, our breadth, our impact, incredible. We have a track on that. Financial services, I just mentioned. Algorithmic trading is going from classical machine learning with human featured engineering called the quants did that, to now supercomputers studying massive amounts of data, discovering insight and discovering patterns by itself. And so this is going through its deep learning and its transformer moment. Healthcare is going through their ChatGPT moment. Some really exciting work that we're there. We have a great keynote track here. We have a great keynote track. Kimberly Powell's doing a great keynote track for healthcare. We're talking about AI physics or AI biology for drug discovery, AI agents for customer service and support of diagnosis. And of course, physical AI, robotic systems. All these different vectors of AI have different platforms that NVIDIA provides. Industrial, we are completely resetting and starting the largest build-out of human history. And most of the world's industries, building AI factories, building chip plants, building computer plants, are represented here today. Media and entertainment, gaming, of course, real-time AI platform so that we could translation and broadcast support and live games and live video. Enormous amount of it will be augmented with AI. We have a platform called Holoscan. Quantum, there are 35 different companies here building with us the next generation of quantum GPU hybrid systems. Retail and CPG, using NVIDIA for supply chain, creating agentic shopping systems, AI agents for customer support. A lot of work being done here. $35 trillion industry. Robotics, $50 trillion industry in manufacturing. NVIDIA's been working in this area for a decade now, building 3 computers, the fundamental computers necessary to build robotic systems. We are integrated with, working with literally every single company that we know of building robots. We have 110 robots here at the show. And then telecommunications. About as large as the world's IT industry, about $2 trillion. We see, of course, base stations everywhere. It's one of the world's infrastructures. It was the infrastructure of the last generation of computing. That infrastructure is going to get completely reinvented. And the reason for that is very simple. That base station, it does one thing, which is base station. It's going to be an AI infrastructure platform in the future. AI will run at the edge. And so lots of great discussion there. And our platform there is called Ariel, our AI RAN. Big partnership with Nokia, big partnership with T-Mobile and many others. At the core of our business, everything that I just mentioned, computing platforms, but very importantly, our CUDA-X libraries. Our CUDA-X libraries is the algorithms that NVIDIA invents. We are an algorithm company. That's what makes us special. That's what makes it possible for me to be able to go into every single one of these industries, imagine the future, and have the world's best computer scientists describe and solve problems, refactor it, re-express it, and turn it into a library. We have so many. I think we have, at this show, we're announcing 100 libraries, 70 libraries, maybe 40 models. And that's just at the show. We're updating these all the time. We're updating them all the time. The libraries is the crown jewels of our company. It is what makes it possible for that platform, the computing platform, to be activated in service of solving a problem, making impact. One of the most important libraries that we ever created, CUDNN, CUDA Deep Neural Networks. It completely revolutionized artificial intelligence, caused the big bang of modern AI. Let me show you a short video about CUDA-X.
20 years ago, we built CUDA, a single architecture for accelerated computing. Today, we've reinvented computing. 1,000 CUDA-X libraries help developers make breakthroughs in every field of science and engineering. cuOpt for decision optimization. cuLitho for computational lithography. cuDSS for direct sparse solvers. cuEquivariance for geometry-aware neural networks. Arial for AI RAM. Warp for differentiable physics. Parabricks for genomics. At their foundation are algorithms, and they are beautiful.
Everything you saw was a simulation. Some of it was principal solvers, fundamental physics solvers. Some of it was AI surrogates, AI physical models. And some of it was physical AI robotics models. Everything was simulated. Nothing was animated. Nothing was articulated. Everything was completely simulated. That is what fundamentally NVIDIA does. It is through the connection of understanding of the algorithms with our computing platforms that we're able to open up, to unlock these opportunities. NVIDIA is a vertically integrated computing company with open horizontal integration with the world. So that's CUDA-X. Well, just now you saw a whole bunch of companies. You saw Walmart and, there's L'Oreal and incredible companies, established companies, JP Morgan and Roche. And these are companies that have defined society to today. Toyota is here. These are some of the largest companies in the world. It is also true that there's a whole bunch of companies you've never heard of. These are companies, we call them AI natives. A whole bunch of small companies. The list is gigantic. I couldn't, this is just a little tiny bit of it. And I couldn't decide whether to show you more or show you less. And so I made it so that you couldn't see any. And nobody's feelings are hurt. However, inside this list are a bunch of brand new companies. They're companies like, for example, you might have heard a couple of them, OpenAI, Anthropic, but there's a whole bunch of others. There's a whole bunch of others, and they serve different verticals. Something happened in the last 2 years, particularly this last year. We've been working with the AI natives for a long time, and this last year, it just skyrocketed. And I'll explain to you why it happened. This industry has skyrocketed. $150 billion of investment into venture investment, into startups, the largest in human history. This is also the first time that the scale of the investments went from millions of dollars, tens of millions of dollars, to hundreds of millions of dollars and billions of dollars. And the reason for that is this is the first time in history that every single one of these companies needs compute, and lots of it. They need tokens, lots and lots of it. They're either going to create and build and create tokens and generate tokens, or they're going to integrate, add value to tokens that are available, created by Anthropic and OpenAI and others. And so this industry is different in so many different ways, but the one thing that is very clear, the impact that they're making, the incredible value that they're delivering already is quite tangible. AI natives, all because we reinvented computing. Just like during the PC revolution, a whole bunch of new companies were created. Just as during the internet revolution, a whole bunch of companies were created. In the mobile cloud, a whole bunch of companies were created. Each one of them had their own standards. And we're talking about one of the major standards that just happened, incredibly important. And this generation, we also have our own large number of very, very special companies. We reinvented computing. It stands to reason there's going to be a whole new crop of really important companies, consequential companies for the future of the world. The Googles, the Amazons, the Metas, consequential companies that have come as a result of the last computing platform shift. We are now at the beginning of a new platform shift. But what happened in the last couple of years? Well, we've been watching, as you know, we've been working on deep learning and working on AI, the big bang of modern AI.